Hi! Let us solve more problems involving integration by substitution. For our example here, we have the integration of sine cube x cosine x dx. In this case, we are going to assign sine x as our u. So the derivative of sine x with respect to u is cosine x dx. And we divide both sides by cosine x to get what we can replace dx with, and that is du over cosine x. Let's now rewrite our problem, replacing sine x with u and dx with du over cosine x. So it will be u cubed cosine x du over cosine x. So you can see we can cancel cosine x, leaving us with u cubed du. So applying the rule for integrating u cubed, we have u raised to 4 over 4 plus c. For our final answer, we have to replace this u here with sine x. And we have sine raised to 4x over 4 plus c as our final answer. For our next example, we have the square root of 4x plus 3 dx. We're going to get the integral square root of 4x plus 3 dx. So we have no other option but to take 4x plus 3 as our u. Let's take the derivative with respect to x, so that will be 4 dx. And dividing both sides by 4, we get dx is du over 4. So now we write our integral square root of u, then du over 4. Moving the constant in front of the integration symbol, that's 1/4. Then the integral of square root of u du. Or we can write this as 1/4 integral u raised to 1/2 du. And applying the rule for integrating u raised to 1/2, we have 1/4. So u raised to 1/2 plus 1 over 1/2 plus 1 plus c, or 1/4 u raised to 3/2 over 3/2 plus c, or it will be 1/6 u raised to 3/2 plus c. Now we can replace our u with 4x plus 3. So our final answer will be 1/6 4x plus 3 raised to 3/2 plus c. For our next example, we have the integration of x times square root of 5x plus 1 dx. So as you can see, these two x's here, they have the equal exponent. So which one do we choose? So actually, we can choose this one as our u, since this is inside the square root. It will be easier for us to manipulate later on. So we have our u, 5x plus 1. And then the derivative of u with respect to x is 5 dx. Dividing both sides by 5, we get dx equal to du over 5. So we can now replace our dx with du over 5, and this will be replaced with u. But if we do that, we still have the x here, and it will not be cannot be replaced with anything in terms of u. So what are we going to do here? Let me show you what will happen first. It will be still x, and then we have the square root of u, and then here it's du over 5. What I mean is the x here is does not the x here stays. It's not cancelled in any way. So what are we going to do? So we have to make x be written in terms of u. So how do we do that? Looking at this one, we can actually manipulate this equation and get the equivalent of x in terms of u. So we have u is equal to 5x plus 1. So 5x is equal to u minus 1. And if we divide both sides by 5, we have x is equal to u minus 1 over 5. Now, our x is in terms of u. So let us now rewrite our problem as u minus 1 over 5. And this is square root of u. And we have du over 5. So we can just bring the constant in front of the integration symbol. So we have 1 over 25. Then we have the integration of u minus 1 square root of u du. So at this point, we can distribute this square root of u to u minus 1. So thinking of square root of u as u raised to 1 half, let me rewrite that as u raised to 1 half. So it's u minus 1 times u raised to 1 half du. There, before we distribute. So we have 1 over 25 integration of u raised to 3 halves minus u raised to 1 half du. And from here, let's apply the rules of integration. So we have 1 over 25. Then we have u raised to 3 halves plus 1 over 3 halves plus 1 minus u raised to 1 half plus 1 over 1 half plus 1 plus c. Then we'll have 1 over 25 u raised to 5 halves over 5 halves minus u raised to 3 halves over 3 halves plus c. And then we can distribute the 1 over 25. And we will have, that's 2 over 125 u raised to 5 halves minus 2 over 75 u raised to 3 halves plus c. At this point, we can replace the u's with 5x plus 1. And we have 2 over 125 5x plus 1 raised to 5 halves minus 2 over 75 5x plus 1 raised to 3 halves plus c. For our next example, we have the integration of 4x times the square root of 6x minus 3 dx. So it's similar to the previous one. Therefore, we have our u as 6x minus 3 and our du is 6 dx. Dividing both sides by 6, our dx can be replaced with du over 6. And again, x, we can write that as, if we manipulate this, u is equal to 6x minus 3. So 6x is equal to u plus 3. Dividing both sides by 6, we get x as u plus 3 over 6. So now we can rewrite our problem as 4 times this as our x. So u plus 3 over 6. And then this is square root of u. And then dx is du over 6. Then let us simplify. Bring the constant in front of the integration. So that's 4 over 36. Or we have the lowest term of 4 over 36 as 2 over 18 or 1/9. So that's 1/9. And then the integration of u plus 3 times square root of u du. And just like before, let us rewrite this as u plus 3 times u raised to 1/2 du. So we have 1/9 distributing the u raised to 1/2 to u plus 3. So that's u raised to 3/2 plus 3u raised to 1/2 du. Still integral. And now we apply our integration rule. So we have 1/9. So we just add 1 to the exponent automatically. So it's u raised to 5/2 over 5/2 plus 3u raised to 3/2 over 3/2 plus c. Then let's distribute the 1/9 to these two terms. So we have 2 over 45 u raised to 5/2. Then we have this is 2 over 27 times 3, 6 over 27. In lowest term, that will be 2 over 9 u raised to 3/2 plus c. And now at this point, we are going to replace the u's with 6x minus 3. So we got 2 over 45, 6x minus 3 raised to 5/2 plus 2/9, 6x minus 3 raised to 3/2 plus c.